High-barrier materials in flexible packaging laminations prevent the permeation of water, water vapor, oil, oxygen, aroma, flavor, gas, or light. A product's formulation can be impacted adversely if these elements migrate into or out of the package. High-barrier packaging refers to materials designed to provide superior protection against external factors like oxygen, moisture, and light. By creating a strong barrier, this type of packaging ensures product integrity, extending shelf life and preserving quality. Industries like food and pharmaceuticals rely heavily on high-barrier packaging to maintain the freshness of food and the effectiveness of pharmaceuticals. This packaging solution is evolving to meet sustainability demands, combining advanced protection with environmentally friendly innovations. What are high-barrier films? High-barrier films are engineered to prevent the permeation of gases, moisture, and UV light, making them ideal for applications requiring extended shelf life and enhanced freshness. Materials used in high-barrier films: compostable polymers, engineered to biodegrade in home and industrial compost environments. These polymers provide excellent flexibility and barrier properties while aligning with sustainability goals. Metallized films provide excellent gas and moisture barriers. Polyethylene, PE, lightweight and flexible. Coated cellulose-based films. These films feature coatings that enhance moisture and oxygen resistance while remaining compostable. They naturally break down in composting environments, providing a sustainable packaging option. How high-barrier films enhance product protection. The key benefits of high-barrier films include: 1. Extended shelf life. High-barrier films minimize exposure to oxygen and moisture, preventing spoilage and maintaining the integrity of products over time. This reduces the need for frequent replacements, contributing to cost efficiency and a better customer experience. 2. Freshness. Maintenance. High-barrier films ensure that products like snacks, crisps, coffee, and similar items sensitive to environmental factors retain their aroma, taste, and texture for extended periods. By protecting these items from moisture and oxygen, the packaging ensures that consumers enjoy high-quality products as intended, even after transportation or prolonged storage. 3. Environmental protection. By blocking external contaminants such as dust, pollutants, and microorganisms, high-barrier packaging helps maintain cleanliness and safety, reducing the reliance on chemical preservatives and extending the product's natural shelf life. Permeability measurement of films. Materials used in flexible packaging have a specified moisture vapor transmission rate, WVTR. Materials such as foil, HDPE, and PVDC have excellent moisture barrier properties. Many products require packaging with low or virtually non-existent oxygen transmission rates, OTR, including various products within the medical and pharmaceutical, food, or personal care markets. For example, many foods require a packaging structure that keeps oxygen out entirely in order to preserve it and extend shelf life. Without an effective oxygen barrier, the results can be changes in color, odor, taste, and overall quality. Permeation analyzers are used for accurate, reliable gas permeability measurement of films, whole packages, and other applications. These analyzers provide oxygen transmission rate, OTR, water vapor transmission rate, WVTR, or carbon dioxide transmission rate, CO2TR, testing capabilities for a diverse range of materials and packages. A permeation analyzer measures the gas or vapor molecules that transmit through the barriers under controlled conditions. Gas or vapor permeations are normally reported as cubic centimeters per 100 square inches per 24 hours. This data gives the ability to understand if the barrier or film will protect the product for a specific application. Better barriers have lower transmission rates, providing better protection. Sustainability and the role of compostability in high-barrier packaging. The packaging industry has long been a significant contributor to global pollution, with millions of tons of plastic waste generated annually. Studies show that over 40% of plastic waste comes from packaging materials alone, much of which ends up in landfills or oceans. As industries shift toward sustainability, compostable high-barrier films are emerging as game changers. These films deliver the same protection as conventional materials while offering environmentally friendly disposal options. Key industries relying on high-barrier packaging. Food industry. Products like coffee, snacks, crisps, chips, and grains require high-barrier packaging to maintain freshness and extend shelf life. Edibles industry. High-barrier packaging plays a vital role in preserving the freshness and integrity of edibles, ensuring long shelf life while maintaining product quality. Pharmaceuticals. High-barrier films protect sensitive medications from moisture and light, ensuring efficacy. Industrial applications. Industries handling chemicals or sensitive materials benefit from the airtight properties of high-barrier films. Challenges and solutions in high-barrier packaging. Challenges. Recyclability. Many high-barrier films are not recyclable due to their multi-layer composition, which can include combinations of materials that are difficult to separate for recycling. Additionally, packaging often faces challenges like food contamination or being too small to be processed efficiently in standard recycling facilities. Cost. Advanced materials can be expensive, posing a challenge for budget-conscious businesses. Solutions. Compostable films. Compostable solutions address recyclability concerns, which often arise due to food contamination on packaging, or because some packaging is too small to be efficiently recycled. Composting provides an easier alternative, especially for those with a compost bin at home, or access to an industrial compost facility in their area. How to choose the right high-barrier packaging for your needs. When selecting high-barrier packaging, consider product type. Identify the level of protection required. For example, oxygen, moisture. Sustainability goals. Opt for compostable or recyclable materials to align with environmental values. Industry requirements. Ensure compliance with industry standards and certifications. Research in high-barrier films packaging. Conventional petroleum-based polymers, including polyethylene, polypropylene, and polyethylene terephthalate, constitute a dominant 70% share of the raw materials employed in packaging production. This results in substantial plastic pollution due to their non-degradable nature. In recent years, the packaging industry has placed increasing emphasis on sustainability and environmental conscientiousness, which has driven the innovation and adoption of biodegradable plastics and bio-based materials. Starch-based materials, cellulose, and polylactic acid, PLA, have emerged as favored alternatives to traditional packaging materials. PLA is a commonly used biodegradable material, but it possesses insufficient mechanical properties, rendering it susceptible to fracture and failure. Starch-based materials demonstrate excellent biodegradability and biocompatibility, but controlling the degradation rate under high temperature and high humidity conditions presents challenges. Therefore, it remains highly desirable to explore facile materials while concurrently exhibiting exceptional barrier properties, mechanical strength, biodegradability, and thermal stability. Cellulose nanofibrils, CNF, derived from the most abundant natural resources, have gained significant attention as a promising biomaterial owing to its low cytotoxicity, excellent mechanical properties, good biocompatibility, green environmental protection, renewable, and many other advantages. Furthermore, the abundant hydroxyl groups on the cellulose surface, combined with the inherent network structure in films or nanopapers derived from it, contribute to their lessened gas barrier properties. Nonetheless, packaging materials based on CNF continue to encounter challenges related to their constrained barrier performance, primarily attributable to their innate hydrophilic properties and complex three-dimensional porous network structure. Researchers have been actively exploring diverse approaches, such as the incorporating other materials, surface chemistry modifications, and enhance the dispersion of CNF within the matrix. These strategies aim to accomplish hydrophobic modifications, reduce porosity, and extend the tortuous path of permeation. Due to its high modulus of clay platelet and abundant natural reserves, montmorillonite, MMT, is the material that has garnered the attention from researchers. The unique in-planar orientation of MMT enables the preparation of CNF-based films with enhanced properties and innovative features. Acting as a barrier to oxygen and water diffusion within the composite layer, MMT effectively extends the air pathways through the film, enhancing its barrier properties, as observed in polymer clay composites. Furthermore, MMT effectively reduces stress concentration in the film, thus diminishing defects through stress transfer and enhancing the mechanical performance of the film. Nevertheless, achieving the anticipated enhancements in both barrier properties and mechanical performance solely through filler stacking is a formidable challenge. Hence, structural adjustments to the film are imperative. The introduction of cellulose nanocrystals, CNC, and enzymatic treatment cellulose nanofibrils, ECNF, results in a denser network structure, leading to remarkable improvements in barrier properties and mechanical performance. Alkyl ketene dimer, AKD, a frequently used sizing agent in papermaking, can modify CNF to improve the hydrophobicity of CNF. Polysaccharide macromolecules, cellulose, starch, chitosan, xylan, sodium alginate, agar, pullulan, etc., are rich in active sites, which gives them designable properties, and therefore have been widely studied by researchers in the field of barrier packaging films.